In this video, we're going to take a look at optimization of an area problem. The problem reads, two equal rectangular lots are enclosed by fencing the perimeter of a rectangular lot and then putting a fence across its middle. If each lot is to contain 1,200 square feet, what is the minimum amount of fence needed? So the first thing I like to do when I have to do an optimization problem like this is draw a picture so I can see what's going on. So we need two rectangular lots, and we need them cut in half by a center fence. So I have a outside rectangle, then I'm going to go ahead and draw a fence across the middle, and we want to minimize the amount of fence needed. So whenever you need to minimize the perimeter or the amount of fence needed, we need to ultimately take the derivative of the perimeter function. And here, since this is an area problem, we're going to need area as well. So we're going to need an area function, and we're going to need a perimeter function. And here I'm going to put some variables on our side. So I'm going to call this side x and this side y. And we also know that each of these rectangles needs to contain 1,200 square feet. So we know that the area of the total rectangle is 2,400 square feet. And we calculate area, we could say that area is equal to length times width, or in our case, x times y. So now we can put these two together and say that area, or 2,400, is equal to x times y. Now we're not trying to maximize or minimize area, so we're not going to take the derivative of this function. We're going to use this function as a substitution so we can get the perimeter with respect to one variable. So now let's set up our perimeter function. And when you're doing the perimeter function, you want to look at every piece you need to build. So here I have 3 x fences. So perimeter is 3x plus, and we need 2 y's. So 3x plus 2y. Now in order for us to take the derivative of this function and solve this, we need this function here with respect to one variable. So I'm going to solve our area for y and say that y is equal to 2,400 divided by x. And now I'm going to say that perimeter with respect to x is equal to 3x plus 2 times 2,400 divided by x. And now I'm going to simplify this. So I have p of x is equal to 3x plus 4,800 divided by x. And now we want to take the derivative. So p prime of x is equal to 3 minus 4,800 over x squared. And now that we found the derivative, we want to set that equal to 0. So we have 3 minus 4,800 over x squared is equal to 0. And now we're going to solve. So we have 3 is equal to 4,800 over x squared. And now I'm going to cross multiply. So 3x squared is equal to 4,800. X squared is equal to 1,600. And in optimization problems, we're only going to use the positive number. So x is equal to plus and minus 40 in this case, but we're only going to use the x is equal to 40. So we know that side x is equal to 40. Now we want to make sure that that's a minimum. So the way I'm going to approach this is I'm going to take our second derivative. So I'm going to say p double prime of x is equal to, which is going to give me 9,600 divided by x cubed. And now when we plug in 40, so now when we do p double prime of 40, we end up getting 9,600 over 40 cubed. And that is equal to 0.15. So we know that we're concave up at 40. So if we're concave up, then that makes this a minimum. So now we've proved that this is a minimum. And now we need to find our y value. So we have y is equal to 2400 divided by x, which is equal to 2400 divided by 40. And we find that y is equal to 60. So the dimensions that minimize the use of the perimeter is 40 by 60, but that's not what they asked us. Let's look at what they asked us. They said, what is the minimum amount of fence needed to enclose the lot? So we need to use our perimeter function again, and we need to plug in the lengths of the pieces. So we have P is equal to 3x plus 2y, and now perimeter is equal to 3 times 40 plus 2 times 60. And we find that the perimeter is equal to 120 plus 120, or 240 feet. So the minimum perimeter that we need to build this rectangle with 2,400 square feet and a center fence is 240 feet. And that concludes this problem.